Hey guys, Joe Pye here at Advanced Innovations. Welcome back to the shop. In keeping with my philosophy of let's get all this nasty cast iron off the machines, the steam chest is probably the next logical component. Now, I would really like to keep the outside of this looking like a casting, but the flash lines got to go. The inside is really the only important part, and there's really nothing that touches the inside. The little valve that slides in there should have plenty of room to do its thing without touching the sides. At least that's the plan. I believe there's about a 16th of an inch, about 1.5 millimeters of clearance this way, and maybe 2 or 3 millimeters on each side this way, at least. Anyway, this is not a gate on the end. This is a feature on the end. I do have to cut this off, make it smooth, shine the whole thing up, make it parallel, pop a bunch of holes in it, stand on one leg, and whistle Dixie at the same time. Tapped hole in the bottom, I believe. Tapped hole in the side. And a little reamed hole on this side over here, and I may have to put a helper block in here to keep everything straight so it goes across in a straight line. That is always the plan. Here is the print. Nothing too fancy about it, and these are not projected views. These are, I believe this is the steam chest cover on this side, though it does not define that unless you look up these two numbers, in which case that's what you'll find. Anyhow, start off, I'm going to cut the flash lines out of the inside with a square file. I may hit the outside on the belt sander, do some hand work on the end here, and then I'm going to blast the whole thing, and we'll start by machining this parallel and popping some holes in it. At least that's the plan. Let's get some files, get to work. After a fair degree of filing and a little bit of blasting, this is what we come up with. Flash lines are removed from the inside, and I'll put that up to the light so you can see it a little bit better. I hit the outside on a sander, both sides, hit the face on a sander just to take the high spots off both of these guys. And you can see the difference in the size of the chest versus the valve itself. Now this is asymmetrical. The posts are symmetrical, the cutout is symmetrical, but the body is not. The body is a little bit longer, or a little bit wider than it is long, or longer than it is wide. I'm not sure which way it goes just yet, but I'm going to position mine so that the narrow side allows me for the most stroke when the valve is functioning. That would make the most sense. So I'm going to hang these initially. I'm going to hang it on a parallel, a rod up against the front, take a couple of dust cuts at the same setting, hanging on a parallel, and that will assure me that these widths are the same size, and hopefully it's going to start to true this thing up. That's the next step. Let's go over to the mill, make that happen. Just like some of the other pieces you've seen me do, there are a few preliminary let's figure out where we are cuts to be made before you can actually go for dimensions. Now on this piece I have one clean side, well, clean enough, and the other one is the blasted side or the rough side. So I really can't trust this to be parallel, therefore you don't want to hold it in a vise. You never know what side of the part it's going to reference to and how that machine surface is going to come out. So I establish one surface at a time. Back surface being my primary is going to go up against the vice jaw. Swing over, there you go. So the side that I just showed you, the shiny side, the flat side, is now against the stationary jaw, hanging from a parallel. This is now locating on the cutout and not locating on the opposite face from this one. There's no parallels in here on this part with the exception of the one passing through. Brass bar is going to press it up against the vice jaw, and I'm going to do this to both sides at a common height to establish a central positioning of that window in this casting. There will be a quiz. Oop, hang on. am using that same 5/16 4 flute coated carbide end mill because I like using it. And if there's a hard spot in this casting, which there may be around the edges because the edges will cool faster than the body, it's not going to wipe out a high-speed steel tool if I go to try with a high-speed steel tool. It's 50-50 on whether or not that ever works out. Let's do it. Let's get over to the bench, check it out. After taking some superficial cuts on both sides at the same setting from the parallel, these sides should be relatively true to each other, size-wise. Now, according to how the pocket was filed in or cast or whatever, the outside geometry may not fall in line. So let's see what we got. 247, 48 and a half. Not bad. Not bad. Outside. 74 and a half. 73 and a half. That is a thousandth out. Now watch this. This is going to be a real treat for all you metric guys over there. I hope that I can get through this without hyperventilating. So here we go. 6.29 dead center. 6.27, 0.02 millimeters difference in those sides. Zero one. See that way. Now, if there's any inconsistency on the inside, definitely it's going to show up on the outside. And we don't know how this thing was sitting. So take a look at this. 27, 27. 27, 29, another 0.02. That is very consistent with what's on the inside. So that's not bad. I will get this extremely close, and then I will register one side on a parallel, and I will make sure that they are dead on. I do have one side that I'm trusting. I rubbed it on some emery on the mill table, actually on the bandsaw table. So that is the side that is being pressed against the vice jaw. And when I know that I have two parallel sides, then I'll sit it on a pair of parallels, and I'll bring everything in central wise this way. All right, cool. I like it. Let's get a little bit closer and finish these up. And my goodness, put this thing back on Imperial. Ugh. Jeez, that was close. Both of the parts are extremely close, within a half a thousandth of each other, size-wise and parallel, which is surprisingly, just a total shock. But good job on the casting, guys. Nice core placement on that, however you did it. Well done. 21 thousandths coming off of both sides. That's about a half a millimeter. And the little red line tells me two things. That tells me that side goes against the stationary jaw, because that's my finished face. And it tells me whether or not the surface has been machined, because just to look at it after a cut, unless you have good eyes and you can tell it or measure it, of course, you won't know whether you cut it. Part is now resting on a parallel, so it's not going to fall in. No more need for the parallel through the window. The window is now central to the casting. So if I take off equal amounts of material on either side, the symmetry of the window should remain where it is. Let's cut these up, and then they're going to sit in there this way, clean side down, and get dusted the same way to bring them into spec this way. Everything else is, we'll see. Let's do it. I made very gentle contact with the top of that part with the bottom of the end mill. Set my quill stop to 0. Lifted the cutter off the part, moved the quill stop up about 3 or 4. Now I'm going to come up with the table once the cutter starts. I can confidently start this cutter right now and come down on top of that part and not touch it. With the squaring operations complete, it is safe to say I can move on to the ports. The end port, the through hole, the side port. The side port is not going to be a big deal. That can easily be done in a vise. And, it's just a port. It really could go anywhere. So the side to side I'm going to calculate and cheat only because I have the pipes and I know what the center to center is from one steam chest to the other based on the pipe that was supplied. So I am not going to put my side steam port on center. It will be, let's just say it will be adjusted. Now the bottom one here, this is for the valve rod that goes through and controls the valve running back and forth. This little guy up here, this 3/32 diameter bore on the other side, is going to have to jump quite a bit of open space and hit an irregular surface. And the chances of that thing going like this when it hits an irregular surface, exactly like that, that is actually very technical right there. It's going to do that when it hits that surface. I want to make sure that when I'm only kidding of course, when my drill comes through here, it stays on track, and regardless of what that surface looks like, it continues to stay on track, and it gets and hits all these dimensions. Well, what an opportunity to go overboard on a fixture, and that's exactly what I did. If I was only going to do one of these, I would struggle through with a 4-jaw chuck and a bunch of shims. But that's not the way it's going to go because I have 2 of them, and I just don't feel like messing around. So, look at this little beauty. Zoom out for a second. Oh, that's as far as it goes. This has been calculated so that when this sits in here and spins, all the ports are right on center. Center this way, life is good. Now coming through the bottom, jumping all this open air and hitting a cast surface on the other side, what did we do for that? We got a little plug that goes in there. And when this thing sits in the fixture, 2 of these screws are going to hold down the casting. 1 screw is going to go through and hold that block down. And that should be all we need in a perfect world. So, yep. There's the collar. So it will be restrained 2 different directions. Through hole on this guy for that center hole. And a shim on the top. I don't know where he got to. He's around here somewhere. Oop, there it is. Now once that is completely locked in there and this fixture is in the machine and secure and indicated, I should be able to pop these things in and out with ease, flip them around and have everything run true and concentric and have access to the faces and diameters that I need to address in the next operation. So let's do a little bit of math. Let's figure out exactly what needs to go where and how much needs to come off. Set this thing up and get on the lathe. Do it. What you're seeing there is irregularities in the surface and a low spot right there. But 80% of this runs within a thou on the high side, which is good. And I'm going to leave it right where it is because I'm just going to leave it right where it is. Let's load up a part, see what it looks like. I like the way it spins. Let's see how rigid it is when you cut on it. This is strictly a cleanup cut. All I want to do is get the flash line off, clean that face, and maybe take a file to that ball, get a little bit more cosmetic peel out of it. Here we go. I'm going to measure the boss diameter and see if I have a radius tool that'll get in there and clean that up. I think the irregularity of the parting line on the top of that is going to bounce the file, and I'm really not going to end up with what I want to see. But that fixture is very rigid. I am extremely pleased. This is not an on-center slot, in case you're wondering. The banking surface here, whoa, it's not San Francisco, people. The banking surface here in the back, in the fixture, is truly half the thickness of the part. From the center line out is half the thickness, plus the thickness of the shim, plus 20 thousandths. And same thing for this side. The bottom banking surface is exactly from the center line of the block to the center line of the puck, and then whatever's left over is left over. This is 2-inch diameter material, and to all you Imperial guys, that is 54.8, is that true? 25? 50.8, 50.8 millimeter stock. And the band around the outside does help with deflection, so that worked out quite well. Let me get a radius tool, set it up, be right back. Okay, it's a hand ground tool. I did not have one the right size, but I think I got pretty close. Now I just have to make sure I don't take so much off there that the through hole pops through. That would be bad. Well, I think that's a good place to start. That'll give me something to go from. I'm going to flip the piece around, take a dust cut on the other side, and we'll see if we can get some numbers on it and know exactly what surfaces to remove for the final dimensions. Okay, the dimensioning scheme on this particular steam chest would dictate that these end walls are the same thickness based on the width of the center. Now, they're calling out 3/4 of an inch on the center, but I know that that's not true. It's a little bit larger than that, so these end walls are going to end up a little bit thinner. The overall length has got to be the same length as the cylinder head and the same length as the cap that they call on there, the steam chest cover. I will calculate the thickness of the ends based on the inside dimension using an adjustable parallel. Just mic across this and you got your inside dimension. You can't trust that it's square, so if it's not, balance it out accordingly, 50-50, split it up, do whatever you got to do. But that's how this is going to be done on that lathe fixture. And I will do this end first. That way when I flip it around and finish this end, I don't have to take it out for anything. I can finish the end and then finish all the ports and be done with it. So this side will get it first, finish-wise. I'm halfway through this. I just pulled this one out to double check it. And now I know where to start. Back to the lathe. For the second side operation, the little pressure block will be installed. And the block will be pressed securely against the registration side of the fixture by the center screw. I'll bring in the overall length and I'll know exactly where to start for all the other features on this part. This next drilling operation, this is the pilot for the valve rod, valve control rod that goes in and out of the cylinder. This is going to pass through the cast iron, through the aluminum block, and through the cast iron on the backside, guided by the aluminum block. So if you see me putting lubrication on this, it is not for the cast iron, it is for the aluminum support block that's inside this piece. That is a 093. Actually, this is an 089. That's about 2 millimeters, just about 2 millimeters. And we're going to go 1.5 inches deep, so that's what, 37 millimeters. Fingers crossed it stays straight. Let's do it. If you guys haven't watched my video on deep hole drilling, small hole deep hole drilling, this is exactly what I'm about to do. I'm backing the carriage up and I'm bumping the tailstock, locking the carriage. I will now slide the entire tailstock in and out so that I can get this drill out of there quickly without the chance of binding up. It's a great technique. Go check out that video. The link is above. If I remember. All right, guys, here's a shop gem for you. This particular port on this piece has the 093 hole at 1.5 inches deep, and for the first half of this casting, it has a 125 hole. I am going to run out of flute before I achieve the depth that I am looking to achieve with this drill. If the chips walk down the flutes and get up into this area right here, and this area is the same size as the lead hole on this part, the risk of blowing up this drill is greatly increased because those chips have no place to go. I'm going to stop drilling this right now because I have a sufficient guide hole in there to control this, and I'm going to put the larger drill in, and I'm going to drill about halfway into that aluminum block with the larger 1/8 drill that's required for the port. That will give me adequate chip clearance for the 093 drill to continue to its final depth. Good tip. Unless you have enough flute, then don't worry about it. I'm going to drill and ream the pilot hole here about halfway into the opening inside the casting. So there will be some aluminum and there will be some cast iron coming out of this. Reaming to 126. Now I'll put the smaller drill in, continue the final depth of that feature, and then go for the tapped hole. I want to make sure that the drill has a nice lead and the threads have a nice lead. I'm going to single point a 45-degree chamfer on this bore to the major, a little bit larger than the major diameter of the thread, 250. So that's about 6.5 millimeters-ish. Next operation in line is the bolt pattern that mates this to the cylinder. Although it's not called out on the print, it has to mate with the bolt pattern put in the face of the cylinder. That cylinder. Now, in a moment of pure honesty, the 2532 on this side and the 2732 on this side, well, you know, things happen, and I made them all the same. So this is a symmetrical bolt pattern. There is no 50-50. Let's try to figure out why. I don't know why they did this. There are no intersecting holes that this interferes with. So a 391 common off-center for all four holes is going to work just fine. And I would like to say I thought that was a great idea and did it intentionally, but no, I saw one dimension and not the other, and that is my bad. So the same bolt pattern has to be put in the steam chest and the cover. So let's get over the mill, pop the holes in, test fit this thing, check it out. Now I'm really hoping that the drill cuts oversized. This drill is exactly the same size as the unthreaded section of the studs that are currently in the cylinder head. So I may have to go back in there with a larger drill and knock these holes out, because this is, like I said, it's the same size. The one time you want a drill to cut oversized, and I bet it doesn't. Murphy's Law, right? Be careful you don't drill down into your parallels. I'm using thin parallels because of the distance to the edge of the part. You're very likely to smash into your parallels. Now, on the off chance that I do have to put this part back in this vise, I'm going to mark my corner location so I know exactly how it came out. If I have multiple parts to do, I always put a black mark or a red mark or a witness mark or any kind of mark on the back left corner so I know that that's back and against the stop. That is my witness corner. Served me well over the years. All right, let's see if it fits. Fingers crossed. Drum roll, please. I had really wanted to blast the outside of this to maintain the cast look to it, but, you know, I'll make that decision at a later date. I think you can see why the 093 hole needed a guide block. That's a pretty far distance for a little hole. That's about 3/4 of the way into the little protrusion on the end. And that's a guide for the end of the valve rod. The other steam engine I built actually didn't have a guide on the other end of it. And that's actually not a bad idea. Just have to make sure that when I do the rod that goes in there, that I size the hole accordingly. All right, hang on, take two. There we go. Can't complain about that. I think I'm very happy. But you can see there's a burr somewhere. I can feel it. One of the studs is hanging up. It's a 102 drill and a 102 stud, and that's just flirting with disaster. I wanted to put a 104 hole in that to make sure everything's sat nice and flush. Have to dig up a 104 drill and re-drill it. No big deal. The setup is already set up. I can feel it too. Sometimes too much precision isn't a good thing. Let it float on there for what it is. A couple of thousandths in the holes is not going to be a big deal. Although I will lose that ideal planar relationship right there. That worked out very well. That fixture worked out very well too. That was a good investment in the end result. Anyway, there it is. Put it in the comment line if you think there should be a blasted surface to go along with the cylinder. I know that there's a wrap that goes around here that hides all of this, because this is supposed to be insulated. If this were a real engine, that would be insulated. And the shield that goes around the outside just holds the insulation in and keeps you from burning yourself further. But I kind of like the way that looks. I might just leave it like that and definitely go back and blast the outside surfaces just so that they look more uniform with that. But who knows? Let's just see if it works first, right? Anyway, there you go. Steam chest. I like the approach. I like the fixturing. And it was a fun job as usual. And to be perfectly honest with you, I only made one this time around. There are two, but for sake of time cutting this video, I made one all the way through to the end. The machines are still set up, and the second one should go quick. That being said, wherever you are in the world, I hope you are well and happy and safe. And let's just add dry for today, because we here in Texas are getting rained on in a big way. So let's hope everybody's got their sump pumps going and their umbrellas in good repair. Thank you very much for spending the time with me today. I am Joe Pye here at Advanced Innovations in Austin, Texas. I'm out.